voltage, current and resistance. What I'd like to look at is the relationship between voltage, current and resistance. Here we have a circuit with a power supply. We have an ammeter measuring the current in the circuit. There's a resistor, there's a voltmeter across the resistor, and it's a very simple circuit. The ammeter is measuring the current through the resistor, the voltmeter is measuring the potential difference across the resistor. I imagine a good analogy is the heart pumping blood around the body. The heart produces pressure, which imagine that's the voltage. The blood flows around the body, imagine that's the current. And then all of the organs and the muscles are like resistors, and the pressure gets used up as the blood flows through them. And when it returns to the heart, the blood trickles back to the heart, and then the heart pumps it round again. And I find that's a good analogy. Here we see there's the power supply provides the voltage which pushes the current round. The current flows round the circuit and the resistor slows it down. V equals IR. This equation links them together. The voltage equals the current times the resistance, and you should be able to rearrange that. For example, you might be asked to work out the current. Let's look at an example. If the voltage is 20 volts and the resistance is 100 ohms, let's work out the current. So rearranging the equation, we get I on its own. So the current is the voltage divided by the resistance, which is 20 divided by 100, which is 0.2 amps. If this was an exam question, then you would be expected to write all that out. Write the equation, bung in the numbers, write the answer, don't forget the units. Now, what would happen if instead of a 100 ohm resistor, what would happen if we used a 50 ohm resistor? Would the current be bigger or smaller? Well, if it's a 50 ohm resistor, there's less resistance, so the current would be bigger. It would be twice as much. If we make the resistance even smaller, 20 ohms, then the current is even bigger. And again, I equals V over R, 20 divided by 20 equals 1, and the equation still works. Back to the beginning again. Now, what would happen if we make the voltage bigger? What would happen to the current? Well, if we make the voltage bigger, then we're pushing harder, the pressure is bigger, so the current would be bigger. It would be twice as much. Again, the equation still works. Voltage equals current times resistance, or current equals voltage divided by resistance. What would happen if we added another 100 ohms in series? If we added another 100 ohms to the first one, what would happen? Would it be harder or easier for the current to flow through? Well, it would be harder. The current would go down to 0.1 amps. And basically what's happened is that 100 ohms and 100 ohms in series, our resistance is now 200 ohms. And I equals V over R, 20 divided by 200 is 0.1. What happens to the voltage here is that the voltage is shared between them, or half of the pressure is lost across one resistor, half of the pressure is lost across the other one. Go back to the beginning. Now, what would happen if we put another 100 ohm resistor in parallel with the first one? Would it be easier or would it be harder for the current to flow through? Well, imagine it's like a dual carriageway. Instead of just having a single lane for cars, now we have two lanes for cars to flow down. So I imagine it's going to be easier for the current to flow. So I imagine that the current would be bigger. And it is 0.4. And that means that the resistance of two resistors in parallel, the resistance of these is 50 ohms. When we add resistors in parallel, the total resistance gets less. And we have 0.2 amps flowing through each. So when the current reaches the junction here, the current splits and half of it goes one way, half goes the other way.